Hello everyone, welcome back to my channel. In this session, let's we know about virtualization in cloud computing. Before that, if you're still not subscribed to my channel, subscribe now. Let's begin the session. Virtualization is the creation of virtual rather than actual version of something, such as the resources like server, a desktop, a storage device, an operating system, or network resources. In other words, virtualization is a technique which allows to share a single physical instance of a resource or an application among multiple customers and organizations. This is the concept behind virtualization. Creation of a virtual machine over existing operating system and hardware is known as hardware virtualization. The process of virtualization is a way to create multiple virtually simulated instances over the computer hardware to utilize your system's underlying resource fully. This increases the productivity and efficiency of our professional and personal requirements. What is virtual machine? Software hypervisor allows the elements of the system such as storage, memory, processor, etc. to be distributed among multiple separate and secure virtual computers created using the hypervisor, which is termed as virtual machines. The virtual machine is the emulation or a virtual representation of a physical device that can execute multiple operating systems on the same computer with a different operating system. Where every virtual machine has its dedicated operating system which uses a part of the system's hardware resources for operation. A virtual machine provides an environment that is logically separated from the underlying hardware. The machine on which the virtual machine is going to create is known as host machine, and the virtual machine is referred as a guest machine. Hypervisor. A hypervisor is a software that allows you to create a virtual layer over the hardware system that manages the interaction between the virtual machines and the system's hardware resources. It acts as a connection between physical system and virtual machines to ensure the proper access of the hardware resources. It also manages so that the virtual machines don't interfere with each other's memory and computing resources. Hypervisor also manages the virtual machines and is known as the Virtual Machine Monitor (VMM). Types of hypervisor. Type 1 or bare metal hypervisor. This type of hypervisor interacts directly with the hardware resources of the system, replacing the host operating system, that is, it is also known as bare metal hypervisor. Type 2 hypervisors. This type of hypervisor runs as a software applications on the host operating system, and it also coordinates with the virtual machines for hardware resource management. How does virtualization work in cloud computing? Architecture of virtualization. Virtualization in the cloud is achieved by combining multiple layers of virtualization. These layers include hardware or physical, network, storage, and application virtualization. These layers can be customized and controlled by the cloud software by the users. The interaction with virtualization starts with the user sending a request for a virtual resource via the cloud software, which transfers the request to the hypervisor. The hypervisor then checks for the available resources and allocates the requested amount of resources to the user. Due to this simplified interaction, the users can set up their entire infrastructure in less time and with less maintenance instead of having to deal with setting up the entire physical infrastructure and maintaining it themselves. Virtualization follows a simple architecture. Let's first look at the left side of the figure. This is the traditional machine. Here we have the hardware at the base layer and the host operating system such as Linux, Windows, Mac, etc. Above, we have the application running directly on the host machine. Here, since we run one application on the host machine, a lot of computer resources are unused. To avoid this, we can run multiple applications by sharing the resources among the applications. This might increase the efficiency in resource utilization, but there are a few issues since the resources are shared. The risk of a data breach is high, and the application cannot operate in a dedicated environment. Virtualization architecture starts with the base hardware as the traditional machine, but it replaces the operating system with a hypervisor. The hypervisor creates virtual machines for these applications and allots resources to them, and these VMs will have their OS, storage, computing power, etc., allowing the application to run in an isolated environment with dedicated resources. This allows efficient resource utilization as well as provides an isolated or dedicated environment for the application inside the machine. Types of virtualization, and those are desktop virtualization, network virtualization, storage virtualization, application virtualization, GPU virtualization, and cloud virtualization. First one, desktop virtualization. In desktop virtualization, you can run multiple operating systems, each in its own virtual machine on the same system. Virtual desktop infrastructure runs numerous virtual machines on a central server and then hosts it to the host system according to the user's requirements. In this way, you can access any operating system from any device without installing the actual operating system in their local machine. Local desktop virtualization is the type that runs the hypervisor on the local system, which allows the user to install multiple operating systems simultaneously without affecting the host operating system. Network virtualization. In this, the software creates a virtual instance of the network that can be used to manage from a single console. Software-defined network (SDN) virtualizes hardware that controls network traffic routing. Network function virtualization (NFV) virtualizes hardware appliances that provide network-specific functions easier to configure and manage. Example: firewall. Storage virtualization. Virtualizations enables all the storage devices on the system to be accessed and be managed as a single storage unit pool for better maintenance. The storage virtualization collects all the storage into a single pool from which they can allocate to any of the VM on the network as required. This step makes it easier for the hypervisor to assign storage for VMs with max efficiency and without wasting any hardware resources from our system. Application virtualization. Local application virtualization runs on the host device but runs in a virtual environment, not in a hardware. Application virtualization. The application is on the server side and it sends some components to the host device according to the requirement. Server-based application virtualization runs only on the server side and sends only interface to the client system. Services offered by the cloud virtualization. Infrastructure as a service. The service provides helps by virtualizing storage, server, and network-related work where you can design them according to your requirements. Platform as a service. Virtualizing databases, programming, and development tools requires this service. Software as a service. As the name suggests that This service provides virtualization for the software-based applications to be hosted on the cloud. Benefits of virtualization. First one, cost savings. The most significant advantage of virtualization in cloud computing is cost savings. By consolidating multiple VMs on a single physical server, organizations reduce hardware cost, power consumption, and data center space requirements. Second one, resource utilization. Virtualization enhances resource utilization by enabling multiple VMs to share the available computing resources of a physical server efficiently. By deleting or removing the underutilized resources, virtualization reduces the wastage, increasing the return on investment for the hardware. Scalability. Virtualization facilitates rapid scalability, an important advantage in the dynamic cloud computing environment. Businesses will quickly provision and deploy new VMs to meet fluctuating workloads and varying demands, ensuring optimal performance and user satisfaction. Next one, isolation. The isolation provided by the virtualization is paramount in ensuring a secure and stable cloud environment. Each VM operates independently, isolating it from other VMs and the underlying hardware. If one VM experiences an issue or failure, it does not impact on the other VMs or the overall system. Improved management. Virtualization simplifies the management tasks, contributing the efficient cloud operations. Activities like backup, migration, and recovery become easier to execute as virtualization abstracts the complexities of the underlying physical hardware. Flexibility. VMs can run different operating systems and software on the same physical server, providing unparalleled flexibility in software development, testing, and deployment scenarios. This allows organizations to cater to various applications needs. Disaster recovery. Virtualization is essential in disaster recovery and business continuity strategies. Organizations can swiftly recover from failures or disasters by enabling easy backup, replication, and restoration of VMs, ensuring continuous operations and data integrity. Thanks for watching. If you like this video, hit the subscribe button and like button. Thank you.